In this video we take a look at how and why convolution give the output response of a system. So in this first frame we can see the impulse response of our system, h of n, and then the time domain input, x of n. What we want to do is use convolution to work out the output response of the system. So we start off at time is n equal to 0, and at that time the input to the system is shown on this next frame here. So we can see it's the first point in the input series that we had originally. In this case it's got amplitude 1 and it's just an impulse function. So what this does when we present this to our system is produce an impulse response, which looks like the middle frame here. But you can see that this is an exact copy of the impulse response in this case. What this produces at the output is this, because that's just the first point in that impulse response. The other 2 points, the points for n equals 1 and n equals 2 in that middle green graph there, they're parts of the impulse response and they are going to be part of the future output, but they're not yet. They're in the future. Right now at n equals 0 we only get the output at n equals 0. Those other 2 points are stored inside the system. The system has memory, it's got some internal state where it stores energy, and those 2 future impulse response terms are going to be used to affect the system output at future time steps. And we see that when we start to look at time n equals 1. So now, if you see, the input has changed. It's now of height 0.5. It's still a discrete time impulse though. So this is an impulse, it produces an impulse response. Different to before though, this impulse response is half the amplitude because it's been scaled by the height of the input. This is a linear system, remember. If we multiply the input by 0.5, we multiply the output by 0.5. What we get now is the first term of this new impulse response appearing at the output. What we get though is more than that, because we've also got the stored term from the previous impulse response. And so when we see on this graph here, our new output is actually made up of 2 components. So we've got one, the small green one, which is the first term in the impulse response due to the input that's happening now at n equals 1, and then a second purple term, which is the energy which is stored in the system due to the impulse that we applied at time step n equals 0. And the total output of the system is these 2 added together. Stored inside the system for the next step is then the future impulse responses from the current step plus what was already stored in the system. If we take a look at n equals 2 now, we can see that the input in this case is the it's the impulse at n equals 0. This one has amplitude 2. So when we pass this into the system, it's going to produce an impulse response again. This time everything's going to have double the height compared to before. We multiply the input by 2, so we're going to multiply the impulse response by 2. When we come to look at the output response again, this again is going to have 2 terms. Firstly, we're going to have a green part due to the first term in the impulse response due to the current input. And then secondly, we're going to have a part which is due to the energy that's been stored in the system from the previous 2 inputs in this case. And we can see that on the output graph now. And again, the future impulse response terms from this impulse go down to affect how much energy is stored in the system. And so we can see how we're building up our output response as a scaled series of impulse responses. Each time a new input arrives, it produces an impulse response, of a height which is directly proportional to the impulse at that time, and the overall response is all of those added together.